Today we are going to the fair to watch knights joust. We are composing functions, and then we will play a nice little game of Connect 4. Hello world, and this is versus Codewars. Here we have two knights jousting. Given a pair of strings of equal length representing a field, each with a knight equipped with a spear, represented by the string representations $, dash greater than and less than dash capital P for the left and right knights respectively, and two integers representing the knight's velocity. The goal of this kata is to calculate the point at which the two knights collide with their jousting spears, representing those points with the same two fields of strings. Let's go ahead and get started here. Alright, these two parameters here at the end are the speeds of the knights. If they're not moving, we don't need to do anything and we'll just return the field. If left equals 0 and right equals 0, let's go ahead and return the field. Alright, we want to keep track of the positions of the left knight and the right knight. We can go ahead and do that by doing this. Let's left knight pause equals field at index 0, index of our left knight. And we'll add 2 to that to get the position of the spear to be exact. Alright, we can go ahead and do right knight pause equals field index 1, index of less than dash P for our right knight. We don't need to add anything to that because that gives us the index particularly of the right knight's spear, jousting spear. We want to go ahead and keep track of how far the knights have moved. Let left knight moved equals 0, and let right knight moved equals 0. Alright, what we're going to go ahead and do, as long as the position of the left knight is less than the position of the right knight, pause, left knight pause. Now let's try that again. As long as the position of the left knight spear is less than the position of the right knight spear, what we'll go ahead and do, we're going to take the left knight pause and add the left velocity that we supplied in the parameters here. We'll do the same with right knight pause minus right. Because the right knight starts at the end of the string, we want it going left. Likewise, we'll go ahead and take left knight moved and add that by left, and right knight moved and add that by right. Now this while loop will break out if the left knight position is equal to or greater than the position of the right knight. So what we'll go ahead and do here, we're going to return an array of a couple strings here. We'll start this one with space.repeat, and we'll repeat that by the value of left knight moved plus field at index 0 dot slice and we'll slice from left knight pause or rather we'll slice from 0 to field at 0 dot length minus left knight moved. And then in the second element of our return array, what we'll do is field at index 1. Slice by right knight at right knight moved plus space dot repeat right knight moved. All right, let's go ahead and feed that into Node and see what that looks like. And it appears we have an infinite loop here. Let's go ahead and back out of here. Why do we have an infinite loop? Oh, yep. That should be plus equals and minus equals. As you can see, we have a new field here. That should be where our knight spears collided. 0, 1, 2, 3. 0, 1, 2, 3. And as you can see, the lengths of these field strings should be the same. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I think this will be good. Let's go ahead and punch this into Codewars and see what that looks like. And try submitting it. And we are good. I don't really have much to say about this one, but here's a clever way of swapping substrings at the beginning and the end of a string around and vice versa. Given a value and a variable number of functions passed in, this function will run this value through each of the given functions and then returns the final value. Let's go ahead and get started here. Let me scroll this back up here. Let's go ahead and get started here. Yeah, this function will take at least one argument, and that is this value here. And we'll take a variable number of different functions here. We need to use the regular function syntax rather than an arrow function because we will need access to the arguments object. Let's go ahead and get that here. Const args equals arguments. We're going to go ahead and console.log that and see what that looks like here. Feed that in a node. And we should have our 5 and a function and a function. Now, if the args array has only one element in it, which would be this value here, args.length is 1, we can just go ahead and return val. Or rather, less than or equal to 1. We can just go ahead and return val here. Otherwise, what we'll go ahead and do here is for let function index equals args.length minus 1. Function index is greater than 1 minus function index. The reason we're doing the for loop like this here is because this Kata expects to run each of the functions in reverse order, like last in, first out. We're gonna run, so given this list of functions here, this method is supposed to run the last function first, and then the first function last. Now, we need to do a little bit of a sanity check before we need to do a little bit of a sanity check during each iteration of this for loop. We need to make sure that a function was passed in. So, if type of args at function index is not equal to function, we're going to go ahead and continue. We're going to go ahead and keep track of our final value here. And then what we'll go ahead and do, we're going to go ahead and set final val here equal to the return value of args at function index. We're going to call that, we're going to assume that this final val will be passed in as an argument to these predicate functions here. We're going to pass this into final val. Then at the end of this for loop, we're going to go ahead and return final val. Let's feed this into Node, see what that looks like here. Maybe greater than or equal to 1. And as you can see, it takes 5, runs this last function here and adds 1, and gives us 6. And then it takes that return value here, runs it through this first function here, which multiplies the value by 2, and that should give us 12. And that should be right in line. No, it is not. Oh, wait a minute. Yeah, okay. I was reading that wrong here. So, it's actually this function that gets called first, and then this, and this, and this, and then this, and so on. So, what we can go ahead and do, instead, we're going to go ahead and do let function index equal 1. Function index is less than args.length plus function index. Feed that into Node, see that looks like, and we do in fact get 11 here. Let's go ahead and, I hope this works. Let's go ahead and feed this into Codewars and see. I anticipate that this will give us some kind of problem. Let's try it. The initial test pass. And we are good. Here is the better code solution of the day. Have a look at the code snippet below me here and have a look at the second argument in that arrow function. This is a REST parameter in JavaScript, and this can be used to use variadic arguments and arrow functions, much like you can do with the arguments object with the regular function syntax. However, the REST parameter implicitly converts those variadic arguments into an array. That array is subsequently run through the reduce method, which calls each of the functions passed in, modifying the accumulator to the return value of each function in order to get the final value of the compose method. Here is an implementation of the classic board game Connect 4. In this game, players take turns dropping discs into a 7-row, 6-column grid, slowly filling that grid up with the goal of forming a horizontal, vertical, or diagonal line of 4 of your own discs. Let's go ahead and get started with this. I have a class here that implements this game. Alright, we're first going to go ahead and do the constructor. We need a way of keeping track of the player's current turn. We'll do that like this. This.player. I think according to this kata, the first player always goes first. Yes. And then we need something to represent the grid itself. What we'll go ahead and do here, this.grid equals, we're going to set this to an array. Each subarray in this array will have 7 subarrays representing each of our rows, the columns in each of our rows. So I think we'll set this to 0, 0, 0, 0, 0, 0 for each subarray here. I'm going to copy this 7 times. And we have our grid. Now this play method here will actually implement the player's current turn. The play method takes one argument, which is the column they wish to drop their disk into. First, we need to determine if that column is full. And we can do that by doing this. If this dot grid at column at element 5. Remember, arrays start at base 0, so the 6th element in the array is actually going to be a 5 element at index 5. Anyway, if this dot grid at column at 5 is not 0, we're going to use 0 to represent a blank space in our grid. We're just going to go ahead and return column full. Otherwise, what we're going to go ahead and do is this dot grid dot at column. I think we're going to go ahead and do what we're going to go ahead and do is find a blank space in our column here. We're going to pass it row as our predicate. And we're going to need the index as well. It's probably a good practice to do the array as well. What we're going to go ahead and do is if row is not 0, we're going to go ahead and return true. Otherwise, array at index equals this dot player, and we'll return false. As I mentioned before, the every method iterates through every element in an array until it reaches an element in which the given predicate function returns false. What we're just going to go ahead and do is console.log the grid after every turn for now. This dot grid. And don't forget, at the end of each run of the play function, we need to alternate between the player's turns. So this dot player equals this dot player is equal to 1. If it's equal to 1, set it to 2, otherwise 1. That way this will toggle the player between player 1 and player 2 every time. Right, I'm going to go ahead and go into one of these tests here. Alright, what I'm going to go ahead and do here is I'm going to do a constant game equals new connect for I'm going to go ahead and do here game.play 1 2 2 3 3 4 4. We're going to go ahead and feed that in a node to see what that looks like here. And we need to set up a win condition here. First, I think it would be a good idea if we set up some kind of sanity check here in case an invalid value is passed into the play method. If column is less than 0 or column is greater than 6. Or maybe what if the column? What if they want base 1 for the Kata? We'll see. Nope, it's base 0. Alright, what we'll go ahead and do from here. We might want to keep track of the last cell that was played. So what we'll go ahead and do is this dot last cell. For now, we set that to -1. Or rather, null. And I think we'll do this dot last cell equals I think we'll do the row here and the column here. I'm going to go ahead and console.log the last cell, see how that works. That doesn't seem right. Okay. Row column then. I want to log the grid again. I think I'm doing something wrong. Yeah. Okay, I think I'm gonna go ahead and rewrite this. We've got our 7 columns represented as subarrays in our grid here. What we're gonna go ahead and do is every pass in our row to our predicate function. We do need the index and the array. I think if the row is not 0, that means it's not empty. We're going to return true and continue with the array. Otherwise, the array at that index equals the current player. Because I think this would represent the row. We're going to go ahead and do this dot last cell. We're going to set that to a pair. Starting at the column. And then for the row we use the index. And we'll return false, which tells every to break out of the loop. What we'll go ahead and do here, we're going to go ahead and log out the current status of the grid and the last cell taken up. I'm going to feed that in a node to see what that looks like. Column 1, row 0. Column 1, row 1. column 2, row 0, column 2, row 1, column 3, row 0, column 3, row 1, excuse me, column 4, row 0, and then column 4, row 1. Now we need to come up with a win condition. We're going to go ahead and set up another function here in our class. Call it check win condition. First, we need to check. We want to try checking the horizontal first. First, check horizontal. I think we'll do it like this. For let I equals this dot last cell at index 0. That would be the column. No. What we need to do, we're checking the win condition here. First, I want to try checking for a horizontal. And I think I'm going to do that. Alright, what I think I'll go ahead and do is for let I equals 0, I is less than seven, our 7 columns, plus I. Go ahead and track the streak for, might be a better idea to name this something other than I, column maybe. Let row equals 0, row is less than 6, plus row. Now, logically speaking, it probably wouldn't be possible to have a anyway, we'll go ahead and we just need to check this. We just need to check the streak of the current player. Excuse me. If this dot grid and column at row equals this dot player. Streak plus plus. Else streak equals 0. Let win equals false. Keep track of whether the streak is hit 4. Streak plus plus. If streak is 4, then win equals true break. We'll need to do the same in the break out of the outer for loop as well. Or I might do that I could do that in the conditional here in the outer for loop. Column is 7 and win equals false. And then after this, if this dot check win condition equals true, then return player this dot player wins. Alright, and if a turn lapses with no win condition fulfilled, we'll just go ahead and do this. Return string that says player, this dot player has a turn. And that is what will return at the end of this. Cannot read property 0 of undefined.
Freaking stuck in a grid and I've been stuck here. Pretty sure I'm spelling it correctly. Go ahead and count along that grid again. See where we're going wrong. We're gonna go ahead and get rid of count along down here. And we'll go ahead and count along our row and column here. Pretty sure that is not supposed to happen. Maybe because of this? Yeah, was that win flag? What if I tried this? Maybe that's strictly equals. What if I tried this? Yeah, that works. maybe not.
And then at the end of the outer for loop here, if when is true, then break. Or rather, I don't need to deal with the break statements here. I can just go ahead and return true here. And then at the end of this function call here, return false.
Alright, what I'll do next is console.log streak. I do need to reset the streak when we start a new column. I'm gonna go ahead and console.log the streak here. That's bizarre.
Yeah, it might be. Wait, I'm doing this for loop entirely wrong here. Alright, let's try this again. For let's row actually equals 0, row less than 6 plus I, or row rather. Reset the streak to 0 for let column equals 0, column less than 7 plus column. If this dot grid at her column and row is this dot player streak plus if streak is 4, return true, else streak equals 0. Let's try this. Alright, still not returning a win condition here. Let's go ahead and console.log that. Console.log this dot grid column row. Gonna go ahead and console.log a new line here. I think it is turning up our win condition here. Try console.logging our streak. Alright, we'll go ahead and keep track of a game over here. This dot game over equals true. And what we'll go ahead and do here is if this dot game over is true, We're gonna log out and game has finished. And keep in mind we're only checking the horizontals right now. Console.log streak. So we're returning true here. Okay. Yeah, we're not console.logging anything. That's the problem. What we're gonna go ahead and do here, we need to console.log all these. Now let's try that. Alright. Now that we have the horizontal part of our win condition settled, let's go ahead and do the row next. Next, check rows. We started with the column and then the row, or rather the row and then the column with our horizontals. Let's do the column now and then our rows. Just as above, we'll reset the streak to 0. Go ahead and move forward, let row equals 0. Row is less than 6 plus row. And we'll do just the same here as we did above. In order to check our verticals, rather. Now comes the rather difficult part of our win condition, the diagonals. Finally, check diagonals. Alright, this is going to take me a little time to figure out here. I think first we need to determine which row the last cell falls upon. Then I think if that row is either row 3, 4, or 5, remember base 0, we can go ahead and check for a diagonal going downward. Otherwise, if the row is row 0, 1, or 2, we can go ahead and check for the diagonal going upward. So what we'll go ahead and do is const check upward equals, we'll set this to true if a row is less than or equal to, or rather this dot last cell remember, we set our last cell's row. The last cell's row is the second element of our last cell pair. So listen, last cell 1 is no. Okay, we do need to keep track of the individual column and row. This dot last column equals -1. This dot last row equals -1. I think we can go ahead and get rid of this then. Set this that last column equals column. this dot last row equals index. Then we can go ahead and keep track of whether we need to check for a diagonal going downward or upward based on the position of the last row. Const check upward equals return true if this dot last row is less than or equal to 2. So if this was 0, 1, or 2, we would want to check for the diagonal going upwards. Otherwise, we need to check for the diagonal going downwards. Next, we need to check to see if we need to check for the diagonal going left or right. I think we'll use a string for that because there could be 3 potential options here, or maybe rather a number. Let check upwards. We're constant check. What would I name this here? Const diag direction. Either left, right, or both. And I think what we'll do is actually make this a let. If this dot last column is less than 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6. If the last column is less than 3, we'll do diag direction equals. We'll go ahead and check for the diagonal going right. Else, if this dot last column is greater than 3, then we need to check for the diagonal going leftwards. Otherwise, if the last column is at 3, which is dead center of the grid, we'll need to check for the diagonal going both directions.
I might not do that, however. I could well do that inside the for loop. What I could do is for let row equals for let column equals. Now that would have to be dependent upon checking upwards here.
Hunker down, grab a drink, grab some popcorn. This could take a while.
I think what we'll try doing here is maybe we'll start from row equals let's get back that check upwards here. If check upwards, or rather, if this dot last row is less than or equal to 2, else for let row equals this dot last row. Row is less than 6 plus row. In this version of for loop, when we're checking upwards here, and we're checking downwards here, the last row is actually greater than 2. For let row is equal to this dot last row. Row is greater than or equal to 0 minus row. So I'll go ahead and cancel that log and see what that looks like. Upwards, checking downwards. Diagonal. Make sure we have that new line here. I think that works. Alright, we'll go ahead and try from here. Oops. For let column going left is this dot last column. Yeah, we'll go ahead and try here is if this dot last column is less than or equal to 3, then we'll go ahead and check right word. For let column equals this dot last column. Column is less than 7 plus column. If, just like we did here, we'll do just like we did here. And then we'll repeat that. Here, it's greater than or equal to 3.
Alright, we're going to write some comments here just to make this a little bit more readable. Check for a diagonal going rightwards. And then check for a diagonal going leftwards. And in both cases here, we're going to reset our streak to 0. Alright, we need to repeat this for the downwards diagonal here. We're going to leave our console.logs in place here for now. Be this down here. No, we got. Copy all this code. Go ahead and put this in the other for loop here. No, that ain't gonna work either. Shh. Alright, back to the drawing board here. This one's a tough one, ladies and gentlemen. Bear with me.
If this dot to last row is less than or equal to 2, in y'all's case here. I'm gonna re-examine that here.
If this dot last row is less than or equal to 2, else for let row equals this dot last row, row is less than 6 plus row, if this dot last column is less than equal to 3, streak equals 0, for let column equals this dot last column, column is less than 7 plus column, if this dot grid at I think it's row, no, column row is equal to this dot player, streak plus, if streak is 4, return true. And else streak equals 0. Check for a diagonal right word. And then check for a diagonal leftward. If this dot last column is greater than or equal to 3, for let column equals this dot last column, column is greater than or equal to 0, minus column. And we will do the same thing we did last time here. Resetting our streak first. I'm gonna go ahead and copy this condition here into this for loop here. I think I may be onto something here. Okay, smooth light row. Is greater than or equal to 0, and then minus minus row, because here we're checking for a diagonal going downwards. I hope that's good. Trying to get a win condition here where the winning player lines up their discs diagonally. And I should have it by doing this. And we can see something is not right with our win condition. Alright, I'm going to do a little more debugging work here. I'm going to do some console.logs here. Or maybe I'm putting the 4-row loop in the wrong place. Let's try something here. Let's try something new here. If this dot last row is greater than or less than or equal to, then we're checking upwards. Upward, else console.log down. If this dot last column is less than or equal to 3, console.log right. If this dot last column is greater than or equal to 3, console.log left. Because there will be cases where if the last column is equal to 3, we will need to check for diagonals both rightward and leftward. Alright, let's go ahead and console.log that and see what that looks like. For let column equals this dot last column row equals this dot last row column is less than 7, row is less than 6, plus column plus plus row. I think this would work. Alright, let's go ahead and try that for the immediate streak at hand. We set our streak to 0 for let column equals this dot last column. For the sake of readability, let's put these in its own line here. Let column equals this dot last column. Row is less equal to this dot last row. Column is greater than or equal to 0 because we're checking to the left. Row is greater than or equal to 0 because we're checking toward the bottom. Minus minus column. Minus minus row. A double dimensional for loop here. Let's go ahead and console.log that and see what that looks like. Column row. I think that has a shot at working here. If this dot grid, check above here just to remind myself here. If this dot grid at column and row is equal to this dot player. Increment our streak, else streak equals 0. And if streak is 4, return true. It's now properly detecting our diagonal and awarding the victory to player 1, which tells me this is working. Alright, let's go ahead and copy this for loop. Here are the branches here. If I can get this mouse to cooperate with me here. Hit copy. Alright, for our right words loop here, we're checking to the right. So column is less than 7 plus plus column. For this one here, we're checking up and to the right. So column is less than 7 and row is less than 6. Plus plus column and plus plus row. And finally, up and to the left. I hope this works. Cannot read property 5 of undefined. At line 74. I might want to reflect this in the other for loops here. Alright, let's try this again here. Let's have a look at some of the other test cases here. Just trying to see if we can fill up a column here. 5, 6, 7. Alright, let's go ahead and I think we're finished here. Let's go ahead and clean up some of our console.logs here. Sure I don't have any console.logs here. I think this is good. Let's go ahead and try submitting this class to Codewars and see what it thinks. We're going to copy, we're going to paste this, and we're going to try to submit it. And we are good. Now this was a doozy that took quite a bit of debugging to get just right. The easy part of checking the wind condition was checking for the vertical and horizontal lines. The difficult part came when it was time to check for the diagonal lines. What I managed to settle on here is that you can use more than one variable in your for loops. Normally you would use for let I equals 0, I is less than so and so, plus plus I. But you can separate separate variables in a for loop with a comma. You could do for let I equals 0, comma, j equals 0, and then you can check both of those variables, or all of them if you're using more than two, in the conditional section of the for loop. You could also use the Boolean operators and or, and then you can change those variables how you wish in the incrementing section of the for loop, again using a comma as a separator. And that will do it for today's episode of Versus Codewars. If you liked the video or you learned something new, drop a like on this video and subscribe to my channel to see me take on more coding challenges from Codewars. As always, if you think there's anything I can do to improve on my code, feel free to drop a suggestion in the comments section below. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.